Good afternoon, everyone. Can you hear me? Can I see some thumbs up? Okay, good. So talk about human factors. I have a red light here. Usually it means that things are switched off, but apparently it's on. Welcome here for the first parallel session after the lunch break. I hope everybody had enough food. I had a little bit. Yeah, it's great to be here. We have now a discussion, some presentations on remote operations. I think this is a very important topic because if we look around in the world for all actual deployments, I'm not aware of any deployment that does not use any form of remote monitoring, remote operation, remote support. We try to clarify a bit on some terms and definitions, because sometimes we use the same word and we mean different things, and sometimes we use different words and we mean the same things. So we try to have a little bit of clarity there. I will be your moderator today. My name is Tom Alkim. I'm from the Netherlands, as you can judge from my orange shoes, but you cannot see right now, but later on. I work for the company called MapTM, and TM stands for Transforming Mobility. I think, Lena, we should start with you. You can come to the stage, and hopefully your slides will appear sort of by magic. And until we see them, you can do the self-introduction.
Right. Hello, everyone. Welcome to our session. My name is Lena Plum. I am from the Federal Highway and Transportation Research Institute, Germany, and I'm a psychologist and researcher working in human-machine interaction, and am in the section automated driving within the Department for Automotive Engineering. And I am very happy to introduce you to our session with a quick overview on research needs and a little what is currently going on in the field of terminology. How does this work? All right, so regarding research needs in teleoperation, please bear in mind that the word teleoperation can be interchangeably used with the word remote operation because tele and remote are seen as the same thing here. So the past years we had a working group coordinated by BUST, and we tried to identify and structure research needs here. This was a working group with experts from all over Germany, and the technical report of this research group is already available in English language. So here we came up with 174 research questions and prioritized them according to their temporal relevance in short, medium, and long term. And this report now stands to encourage structured, holistic, and interdisciplinary research. In this report, we considered 3 use cases of teleoperation, which is remote assistance on demand, continuous remote driving, and event-based remote driving. I will tell you a little bit more what we considered here later. I have no power over this. I don't know. No, nothing happens. I don't know.
But yeah, you managed to do it. Yeah.
Yeah, it was magic.
That was the last bit of choose. Julie, can you advance the slides? And then in the meantime, I will look for a battery. Yeah. Okay, we have to improvise a little bit here, as we have no way to advance the slides at the moment. Because Julie, you can have someone else who has 2 AAA batteries. Yeah? No, I wiggled a bit with the batteries.
Like this? Yes. Big thank you to Azra for saving us technically. Yeah, so the research report was, I completely lost my train of thought. Structured by the so-called socio-technical system of teleoperation, which we came up with. And it shows that the world of teleoperation here can be divided into, we call them so-called clusters. And you can see that some of the clusters are more technically oriented, such as communication technology, vehicle, area of operation, and functional safety. Some are more human-focused, such as fitness to drive, competence, personal requirements, or social aspects. And some of them are very interdisciplinary, such as workstation ergonomics and occupational safety, where you can see humans and technology have to work together there very closely. So for each of these clusters, as well as an cross-cluster, we define very specific open research questions, which can all be found in the technical report to encourage future research. I'm trying really hard. No.
I think it's pointing at this one.
I tried. This is terrible. Ooh. Ooh.
What was that?
I don't know. Ooh. Okay.
Is that the next one?
It'll take a while today, I guess. So, next step with our research report is that we want to make this into a database so that we can continuously structure scientific findings in the field of remote operation. So we imagine a database that is structured on the structure of the technical report, so that you can organize the questions by the 5 clusters, also by their temporal relevance, and also the use cases. And we imagine here that that everyone can find short answers to the identified research questions, which is then easy and quick to access based on current research results, and also find references to the literature. If you're interested more deeply in what we're trying to set up here, you can feel free to contact me later, but I will not go deeper into this right now. Oops. Ooh. No. Can you change them? Okay. Yeah, please. Yes, let's stop right there. So right now there are a lot of terms circulating around the topic of remote operation, and there are many terms that are used sometimes for the same things, sometimes for different things, and actors are assigned different roles, but we see that there are a lot of terms and it's really hard to separate these at the moment. So for terminology, however, it is very relevant that we have a consistent and standardized terminology so that we can ensure a common understanding of the definitions, we can delineate roles in the field of remote operation, and have a common basis for to make scientific findings comparable. Also, this ensures that we can actually transfer these the findings that we have to other fields such as regulatory work, which makes it a lot easier if we have common understanding about terminology. Right now, there's a lot of work going on terminology, for example, in standardization. We've already heard about standardization this morning, and you can see here a list, which is not complete probably, of a lot of standards that are circulating right now and attempting to define a lot of terms in the field of remote operation. But still, these have a lot of differences and some commonalities also. One outcome of the research group that I just talked about was that we came up with a joint definition of the term teleoperation, which can be seen as an umbrella term that includes both the provision of information and advice to an ADS-equipped vehicle so that the ADS can facilitate trip continuation, but also the performance of vehicle motion control from outside the vehicle. So these terms, remote assistance and remote driving, are both included in the term teleoperation. And the remote assistance here means that we assume a vehicle of level 4 or 5 ADS-equipped vehicle is controlling the vehicle and operating the motion control. So the remote assistance actually does not intervene directly in the vehicle guidance, but provides information if requested and needed, such as advice or releasing driving maneuvers. So still the ADS is required to perform the driving task and decide on the information that is provided to the ADS. Remote driving, on the other hand, here means that the remote driver is performing the entire vehicle motion control from outside of the vehicle. In this report specifically, we also decided that the remote driver must be located out of sight of the vehicle. More work on terminology is being done right now to actually wrap their head around the many tasks and the many terms that are circulating right now. For example, Schwind et al. Have came up with this nice table where you can see that some familiar terms are organized here, and you can see that the terms that you can find very often in the research reports, such as monitoring, releasing, deactivation, are used here to actually cluster where terms overlap and where they're used more or less across the board. And these roles actually have to be separated more specifically now, so that it is clear which role exactly lies with whom and who is responsible for what in this very complex interaction. For example, Wolf and colleagues have distinguished between the remote operator and the fleet manager in their publication, and these and also the technical report are now basis of another working group that BUST is involved in, as well as a lot of other members. And we try to distinguish the role of the remote driver from the remote assistant here. We consider the technical side, so the remote operation system and the driving automation system, as well as the human side, the remote assistants and the remote driver, as well as their interaction. And we do this based on how information is actually processed, how actions are selected, and how they are then performed. To give you a little forecast, we find that remote driving is actually intervening directly via action execution, while the remote assistant only provides information to the driving automation system at the level of information perception and action planning. So this is our way of focus in this publication that is hopefully to be available soon. And yeah, you can stay tuned for this one. So I hope I gave you a little overview on the current research needs and work on terminology with lots of interruptions. But I'm happy to take questions.
Yeah, I think we should first give you a hand for this very rocky start. And for demonstrating the importance of reliant remote operations. We are depending on technology. Are there any questions from the audience? We can take one or two, although we don't have a microphone. Yeah, if you stand up, I'll try to repeat the question for the audience back home. Before you answer, I think for the audience online, it was your observation that this might be a German-centric presentation. Can you say something on how global it actually is?
Thank you so much for your question. I think that is a very valid question because every country kind of does their own thing and working groups are sometimes only within one nation. But what we're trying to do here and what we also did for the working group in research needs in teleoperation was considering research from all over the world and taking a look at what do we already know about this field also from other fields. And what can we adapt to the current open questions? And also for the new working group that we are trying to separate remote assistance and remote driving right now, what we first are doing there is take a look at all the standards that are international standards, to look at these definitions and see what do we get from here, what terms are reoccurring, what overlap is there, so that we can actually include also the international perspective. But you are right now this working group is a German working group only, but we hope that it will be fruitful for the international audience as well.
Yeah.
Just to add something, I'm a member of the ISO and I'm a member of the BUS group. And at the moment, in parallel, there's the ISO spring meeting in Leeds, and they're discussing also the work on teleoperation or remote support, as it's called there. And it resembles what we are talking about here or what you introduced to us, Lena. So it's not a German view. It's also an international view from the US and from Japan. Yanbin Wu, you will also tell something. It's aligned all over the world at the moment, just to add.
Okay, thank you for that. Was there another question from the floor? Otherwise, at the end, we also have some time for discussion. Then I think we can now go to the next slide while the next speaker is slowly... Oh, okay. We can do that later. Pia, you can come to the stage. Yeah. Is this the last one? Okay, applause.
Yes, okay. So thank you for having me here, speaking about NRIDE and the remote operations that we do. And before I move into the presentation, I would like to tell you who might not be familiar with NRIDE, what we actually do. And we are a freight technology company providing electric freight transports to our customers. So that's our primary use case. But what we also do is provide electric autonomous transports to our customers. And the unique selling point of our case, and which will also be shown throughout the presentation, is that we do all the parts of the operation. So we have the vehicle, as you see here, and I was very happy to see the inspiration taken this morning in the video that we saw from our vehicles. I can presume anyway. But so we do deliver the vehicles, and we have the remote operation station as well, and as well as the contact with the customers and doing the transports on a daily basis. So, one deliberate click. Okay, let's. Maybe it only. Oh no. Okay, let's see if I. Okay. So we do daily operations with our autonomous vehicles, for example, in the US and in Europe since a number of months, and we're very happy about this. And doing so, we have learned a lot, of course. And yeah, we just heard Lena speak about all the different names and nomenclature there is out there. These are the terms that we are using. And let's start from the very bottom. I would like to say that we do offer remote drive to the vehicles, but this is something that we do very limited. And it's to support the vehicle when it's outside of the ODD for any particular reason. For example, if it starts raining a lot or something. And it's just to move the vehicle to, for example, the garage or something. So very limited use of the remote drive. Going up in the hierarchy, we see that we do a remote assist, and this is where we support the autonomous vehicle, for example, through approval points, adding an extra safety layer with the remote operator. We also communicate to the warehouse staff, for example, saying that we have now approached the gate and that we want the gates to be opened and that our vehicle can be either loaded or unloaded. And speaking of loading, our remote operator also oversees the loading and unloading because the liability is on the remote operator for the load securing. So this is also something that we feel is really important. Remote management, and this is where it gets really interesting and also very important for us since, as I said, we are offering the entire transport to the customers. And here we have operational planning and replanning if there's something unplanned that has occurred. But it also handles alarms, for example. And I just want to stress that what you see here is really the autonomous vehicle working in an operational environment. So from our perspective, we believe that the nomenclature could and should also introduce these types of tasks, because this is something that we're working on and that we need the remote operator to be able to handle. And going forward, we are taking big steps in the business case that we have, supporting not only one autonomous vehicle from the remote operation station, but 2 and also more. What we see first is that the remote operator could work with 2 or more vehicles in sequence. That is, when a vehicle is standing still, the other vehicle is moving. And this might sound, preposterous, but it's really a way for us to take a step in providing a viable business model. And of course, the future is what we call parallel driving, right? One remote operator with many vehicles moving at the same time. In the Moody project, which I think you will hear a lot about during these days and mentioned already this morning, we have been looking into tasks and interactions that is needed from remote operators' perspective when we move into fleets of L4 vehicles. So if you're interested in that, please reach out and I can give you a link to the presentation or the report, sorry. Yes, and of course, every day we continue to improve the HMI of the remote operation station. The human aspects is really, really important when adding this safety layer to the vehicle. What we see is needed and what we would like to contribute with is definitely the research part, creating knowledge about the role of the remote operator going forward. And as we stated in the previous session and myself here, the words that we are using so that they really support our case, of course. We would definitely want to understand more about the cognitive load of remote operation for the person sitting there. And also how they should, working in shifts or not. What's the framework there? And this is true now when we have one remote operator for lesser vehicles, but it's also true going forward when we scale up to fleet management. From the regulatory perspective, we would definitely like to see regulations that allow us to test and deploy our autonomous vehicle with a remote operator with no safety driver in the vehicle. This is what we want, and we want that, of course, in Europe, throughout Europe, and also internationally. We're also interested for the regulators to elaborate and decide on the liability of the remote operator. This is really important to be able, for example, to know where the liability lies for cargo securing, for example, going forward. So with that, I would like to say thank you. Thank you.
Yeah, I suggest that we go directly to the next presentation now, and then afterwards we have a panel discussion with the 2 of you. So, Asra Bubiefic but you can explain that yourself when the slides are emerging.
Now? Yeah. Hi. Good afternoon. I'm Azra Habibovic, and officially I work for Scania Commercial Vehicles. Unofficially, I work for Traton Research and Development, and I'm saying unofficially because that's coming to be official from 1st of July. Who in this room knows what is Traton? At least a few hands up, but to ensure that all of you know that, I have prepared a slide. Hopefully it will show up. It's a heavy vehicle company, fully owned by Volkswagen, has been around for several years, probably 10, 15 years. And now we are building a common research and development department for 4 Traton brands. These brands are Scania, where I used to work until, quite recently, MAN in Germany, International in US, and Volkswagen Truck and Buses in South America. So that's us. We are quite a big organization, and I think it's very positive in this context of autonomous vehicles to be a large organization, because what we have seen from the past couple of years, it really takes a lot of effort, a lot of investment, and a lot of knowledge to not only show pilots, because we have seen that. I mean, with decent amount of money and knowledge, I should not say anybody, but more or less anybody can put together a test vehicle and demonstrate some things. But what really requires a lot of effort is having operation, deployment with customers. And that's why I think we have a good standing point from Traton perspective to do something out there in real world. And we are doing that already today. So on this slide, on the, your right, no, your left side, you can see our vehicle in mining context. We started doing verification and validation with one of our customers in Australia 6-7 years ago. Last year, this was launched as commercial product. So if you are owning a mine and would like to have an autonomous solution, please talk to me. Yes, but also, so that's already a product. But currently, we are working also on customer pilots on what we call hub-to-hub application. And basically, that is operation driving from one logistic hub to another one. A bit suburban road, but mainly on highway. Why are we doing that? Because that's rather simple, or compared to being in an urban area. But for us, even more important, it's where we see business case for our customers. So what we are doing is we are developing scalable, adaptable solution, autonomous transport solution for operation on highway. It should be available and operate 24/7. And currently we are testing with human safety driver behind steering wheel. But in our vision, there is no human driver behind the steering wheel. Earlier this morning, it was mentioned that there is huge lack of truck drivers, but having also a truck driver inside the vehicle costs a lot. So for our customers, the biggest benefit is actually to remove the driver. And now I know you are going to jump on me and saying people will be without a job, but some statistics from Europe 2 years ago show that there was a lack, 300,000 of truck drivers only in Europe. I don't know how many in US, but probably even higher numbers. So looking ahead in future, we don't see it as a problem taking away jobs, rather creating actually new jobs and making sure that we can support our customers in delivering goods even in future. So coming to remote operation, what we envision is probably slightly different compared to what Pia presented. because we don't envision remote driving in our autonomous transport solution. What we envision is to have a human remote operator that provides some kind of strategical support to vehicle, what we in our internal language call management, and also a human remote operator providing some kind of tactical support, typically showing on the map, for instance, waypoints, and helping the vehicle to understand the situation better, but still the final decision is with the vehicle. And in our language, it's called remote assistance. So that's how we envision remote operation. As I mentioned previously, we have been doing this for a couple of years, and we have learned quite a lot from doing these pilots with our customers. One of the lessons learned, and I'm not going to repeat what Pia already said, because all these lessons learned that she mentioned really apply to our case as well. So I have selected slightly different lessons learned, and that one of them is that operating a large fleet of vehicles is different from operating a few vehicles. Having remote operation of one vehicle, 2 vehicles, 3 vehicles, it is challenging, but we know that we can solve it. We can have 3 remote operators, human remote operators, taking care of that. But if we talk about 300 vehicles that need a remote operation, then it becomes different. And especially it becomes different if we go away from verification and validation. As I mentioned before, anybody can do that. Well, not really anybody, but you see my point. But really going to commercial operation, we have seen in a very simplistic environment in open pit mine in Australia, it really takes a lot, and it takes a completely different mindset. Basically to foresee things that we haven't seen before. And that's also one of the key challenges that I have selected to talk about here today. We can handle things that we are aware of. I mean, if you are familiar with the problem, there are brilliant minds who will come up with the solution. But the biggest challenge for us is going to customer deployment without knowing what is unknown, what are we missing. So that's a big challenge. Of course, we are trying to do a lot of simulations and to envision what might happen, but still, it is really a big challenge. And along the same line, understanding operational complexity before deployment, that's another big challenge. Because again, we work directly with our customers, so there is no space to have something in between. If you are going to sell a transport solution, you have to be sure it works for any customer. So really knowing that in advance is a big challenge and requires a lot of work and different types of simulation and prediction. And for heavy vehicles, uptime, the number of minutes, hours that our vehicle is in use is really important for our customer, because each second, each minute that the vehicle is not being used is very costly. So for us, when we speak about remote operation, it's also about maximizing the uptime, minimizing downtime and maximizing uptime for our vehicle. That is key. And I am getting to the end of my presentation. I promise you, Tom, I see your look there, counting all seconds. But from our perspective, remote operation is there to bridge the gap with limitations of the existing technology. And I'm putting here a question to you. You don't need to answer it, but I want you to think about it. is remote operation for the future? Should we invest in that, or is that just a phase until we get up capability of the technology? So how much should we invest in a remote operation? And especially if taken into account that autonomous driving systems will improve over time. So as the capability of autonomous driving system improves, what will happen with remote operation? Pia mentioned here that they already envision that remote operator is taking care of the tasks that regular fleet manager do today. Maybe that's the future, but I really can't stop wondering, is remote operation here to stay, or is it just in a transition period? And with that, I am done. Thank you.
Yeah, Pia, if you can also come here, sit next to Azra, we can take a couple of questions. And I like the idea of posing a question to the audience. Does any one of you have an answer to the question that was just posed? Yeah? We have a microphone now. Where's the microphone? Yeah. Here. If you raise your hand. Yeah, here on the second row.
Well, to the question, yes, we will need operational help anytime. My colleague said, as long 2 batteries missing are not helping us to have the fallback, we will need the technical support. The main question will be, in the future, if the vehicles are as good as possible, the amount of operational help will be reduced. And at the moment, never ever, I saw it all over Europe, never in the world, transparent, that the aspect of remote help is going back. So in Switzerland, we have no idea how much remote help these vehicles in pilots in China or in Waymo in US, how much they need. And this is important for the business model, for the one who is running the vehicles. So remote operational help back to even driving, in my view, could be helpful.
I guess I should give you my perspective on this. I agree with everything you said, basically. And I also foresee that remote operation in one or another shape will be around, but the shape will change certainly over time. And we have seen that from air operations and so on. It is changing over time. So I guess what I try to kind of put forward here is that we need to anticipate that this type of service will be changing over time. So we should not assume it's static and that we have solution that is there to stay forever. It needs to develop over time and to reflect capabilities of the vehicles, but also social perspective, social acceptance of these vehicles, and so on. So yeah, that's my reflection on that. Thank you.
Could I add? We were speaking here about the capabilities of the autonomous vehicle, and that is a part of it. But what we have seen here is that we are deploying our vehicle and remote operation into the logistics system. So it doesn't really only matter if the vehicle is fully 100% perfectly autonomous. It is the digitalization of the entire industry that needs to happen for this to be seamless going forward.
Okay, are there any other questions? Yes.
So another one, is it working? Yeah. Another question to you, Azra. What is your vision on the ODD problem. So as you're saying, or you have crossed out the whatever the operational driving assistance in your slide. If you have running a fleet and there's something going on like a snow shower in Sweden, systems have to whatever switch off or stop. How to solve this problem with your vision of remote assistance?
Magic. Yeah, it is indeed a challenge that, ODD, as you say, might suddenly change. But now I will give you an answer as one of the engineers here. It is embedded in the design of the system, how to handle of the autonomous driving system, how to handle such situations. So of course it has touch points with remote operation as well, but our standpoint on this is that the autonomous driving system needs to be able to take care of such things independently of remote operation. So for us, remote operation is not there really to 100% solve the problem. Is just to provide additional information to the autonomous driving system. But still, the final decision what to do will be with the autonomous driving system. So said that it needs to be embedded in the safety case for autonomous driving system. But really important and very challenging. I mean, it is one of the reasons that we have that few vehicles really out there running in challenging conditions. What we see in deployments in other parts of the world, it is under relatively, I'd say, constant environmental conditions that autonomous driving take place there. I hope that was the answer.
And also to add from our perspective, I didn't have a cross over my remote drive, but it's more or less the same. I mean, we are envisioning a very, very little use case for remote driving. That's not what we primarily see. I mean, it's the remote assist and the remote management. But I didn't make it as explicit as you with the red cross, but I just want to make it explicit now.
Okay, we have two more questions, and then we go to the next panelist. We'll go with you first, Dimitris, and then.
Thank you very much. Dimitris Milakis from DLR, German Aerospace Center. Thank you for your presentations. I suppose while you design your systems, you speak with your clients. What are their needs and what are their concerns? So I would like to have your insight on this. What kind of needs they see this covering and what is their major concern?
I can try to answer. So I would say that it is really important to find these first customers that are innovative and that are willing to change and to will adapt and to have a dialogue, because this the autonomous vehicles are not 100% as manual-driven vehicles for the moment. We need to, yeah, you've heard it a lot. We need to collaborate to make it fully able to fit into the customer's operational system. So I would want to say that. Let's forget about their challenges and what they have, but it's the dialogue to make it work together that is the key point here.
Yeah, I can give you a concrete example from our customers in mining. As I mentioned in my presentation, we started a verification validation pilot with them some years ago, and the reason they wanted to do this was, well, there were several reasons, and don't have time to go through all of them, but one very interesting problem that they had. I should say this way, for our customers, it starts with a problem or a challenge that they want to address. So for them to be part of this, they need to have a concrete burning point, something that they want to, usually it's to save money, but in mining space, it's actually to improve safety as well, and efficiency. Well, both safety and efficiency is money if you put it in a mathematical equation. But in mining context, for them, our customer in Australia, they used to have large vehicles before, and so a need to have several smaller vehicles. And then they reached out to us because we don't have these huge construction vehicles that you usually connect to mining. They wanted to test smaller electrical vehicles. So they wanted to switch to electrification, but these huge vehicles, they couldn't run on electrification out there. So it was driven actually by the desire or need by our customers to deploy electric driven vehicles. And then they went, okay, we need smaller vehicles. Well, we can make these vehicles autonomous, which will improve safety and working conditions for our workers and so on. So that was kind of starting point for our customer. And of course, if we would talk about customers that we have in US right now, where we run pilots on highway, it is a bit different need they have there, because over there we are doing pilots in Texas, as I guess many other heavy vehicle companies. They have long distances driving on highway, and they wanted to secure that they have ability to provide transportation in future. As I mentioned, this lack of truck drivers, and especially it's lack of truck drivers for long distances. So if you imagine driving for days or weeks being from home, nobody wants to do that, or very few people want to do that. And our customer identified that as an, I'd say, very given challenge in future, and they wanted to address it already now. So it is completely different depending on the use case, but always starting with the real problem. I think that's the key for actually getting to deployment. If you are not addressing the real problem, you will end up with, in the best case, running some pilots, which is really good for improving knowledge. But if you want to make profit out of that, you need to have a customer with a clear need.
Okay, well, thank you for that. Unfortunately, time is slipping away, but thank you for your insights from practice. Thanks. And we are now continuing with two more presentations on remote driving, whether this is a feasible solution for driverless vehicles. First, we'll have a presentation by Michael, and then afterwards by Jan Bin, and then we also have a panel discussion afterwards. The floor is yours, Michael.
Red is on. Oh, okay. It's a human factors trick. Red is on. I'm Michael Oehl from German Aerospace Center. As you heard, I'm a member of the ISO group with regard to human factors questions of remote support. But in my main job, I'm leading the human-machine interaction research group at DLR. And I'm talking about remote driving versus remote assistance. And I'm tackling human factors challenges, from a human factors perspective. Why I'm doing that? Not only because I'm a psychologist, but I also I think we've introduced a new agent in the whole system, and the human being is a new agent in the system. So there are lots of human factors challenges we should be aware of, as Azra and Pia already said. From DLR side, we are following in this socio-technical system of automated driving, a system of systems approach, meaning that we have here the workplace for remote assistance and remote driving of this new human being in the whole system. But in the system of systems approach, we also have, of course, the vehicle automation and perception and its capabilities. And as we heard what Pia said, we are aiming at a very capable ADS system, but in fact, it's not very capable at the moment. We see Waymo, for example, we see projects in Germany, but still there are some limitations, and the automated driving system often reaches its ODD. As Andreas, you said, what about snowing weather conditions or in general adverse weather conditions? We have, where appropriate, intelligent infrastructure, where it might help to solve the driving task of the vehicle. For example, at big intersections, we have that at DLR, for example, in Braunschweig. We have, of course, in this whole system, the passengers, the users of these cars and other road users, because we want to safely interact with all road users out there. And very important, and we saw it here with the remote control of our slides, we have the connectivity as a very important system, gluing everything together. Without connectivity, and we will hear that, it's not possible to do something remote. So to show you where we are coming from and what we are currently doing in several research projects, just to mention a few. When you're talking about doing remote assistance versus remote driving, it's all about the use case as well. In Germany, we were, I think, one of the first countries that had a law on autonomous driving, making it legal to have remote assistance out there. So we can have on public roads, and that's very important to know and to have in mind, on public roads in Germany, you can have automated driving, level 4, including a remote assistance. It's not legal to have a remote driver on public roads. But for some use cases, like we did a project with a World Food Program, and here you see an amphibious vehicle, it's called SHERP, and we did it in the South Sudan, and the vehicle is not very capable with this automated driving function. And it makes sense to have remote driving there. In the EU Lighthouse project, HiDrive, we follow an approach for public roads. So we do research on remote assistance there because the use case is public roads. If you have a look at managed automated driving in an urban context, there we follow a different approach. We have an automated vehicle, which is highly capable of doing the dynamic driving task. We also have infrastructural support where appropriate, and we have a remote assistant. By the way, the project Managed Automated Driving has a demonstration out there this evening and the following days. And also, I think for HiDrive, we have a demonstration also out there. And we have a new project, Emoja, which is in Braunschweig, and a new one. And we have automated driving with remote assistance in the city of Braunschweig there. So when you're talking about driving versus assistance, everything comes with human factors challenge. For example, we're talking about latencies. As we see, also the remote controller of the slides has a really high latency, but now we can deal with it. I'm the fourth speaker now. Now I know how to wait. If I would be the first one like Lena, it's completely unpredictable. And so the same for remote assistants or remote drivers. So latency is a really big problem, and especially in Germany, I don't know how it is in Italy. We have really connectivity problems in some places, especially in rural areas. From a human factors aspect, it's about staying in the loop, and it's all about situation awareness, meaning you have to see these other road users or the agent in a traffic situation. You have to understand what's going on out there, and then you have to interpret what you should do for a safe interaction. It's about vigilance and waning vigilance. The question always is it possible to do monitoring tasks? From the ISO and from a human factors perspective, we say, okay, well, maybe 1 hour, half an hour, but don't rely on the human being, because vigilance tasks are the baddest one you can ever give a human being. It's about optimal task load. We heard that from Pia, that it's a big question. Could they do night shifts, for example? How long can they do it? For example, in a German project, Kira, we have out there SAE4 vehicles, and we have the safety drivers inside the vehicles, and they constantly have the task to monitor the vehicle performance, the ADS performance. And after 2 hours, they are completely done. They are not able to do this task anymore. And they're driving at speeds 80 kilometers an hour on rural areas. A question of distances. In the German law, for example, you have remote driving as well legal, but only in a distance of 6 meters and low speeds, which is not really a business case. And it's about balancing tasks. You mean that, for example, you have a remote manager, you have maybe a remote driver, you have a remote assistant and a coordinator, not everything together. So advantages and disadvantages, just a few. We will have that in our discussions later. Remote driving seems so promising to some extent at the moment, and there are big discussions, at least in Germany, to legalize remote driving also on public roads, because the implementation seems quite easy. You can use something like a level 2+ car and drive then on public roads. But still, it's a level plus car, and you have to do all the monitoring, the dynamic driving task. You have to ensure always good connectivity and so on. So it comes with a lot of disadvantages, and as I said, it's not conforming with the German law at the moment. And you have always a one-on-one interaction at the moment. So it's not a good idea in the direction or with respect to scalability. If we're talking about remote assistance, it's quite more challenging from a technical point of view. As I told you, you need a very good ADS function, which is capable of mastering most ODDs. And the assistant is only assisting or helping the vehicle in some few moments. You have short durations of interventions, which makes it possible to assist several vehicles, a fleet of vehicles. And the safety insurance is always on the side of the vehicle in the concrete situation, which makes it also challenging. So if this results in an HMI, the information needed by the assistant versus the remote driver, you have on the right side a remote driver workplace with a steering wheel and pedals and so on, which is nothing new, I think. But on the left side, you have here, we developed it at DLR in my work group, compliant, German law compliant workplace for the remote assistant. And you have here some monitors and a ticketing system to assist a fleet of vehicles. And you can use this touchscreen here to set waypoints for the vehicle for assistance. If you're interested in it, we have our workplace of the remote assistant out there at the entrance stairs. Thanks a lot. I think we'll talk more about in the discussion later. I hand over to you, Jan-Ben.
Thank you, Michael, for that. Jan-Ben, yeah, you can come to the front. Your slides will appear soon with a little bit of latency. And I'd like to inform you that we will go until 4:15. So we still have some time to discuss. Go ahead.
The information already been delivered, especially by Azra, but I hope my presentation can deliver more explicit information about our thoughts on remote driving versus remote assistance. So my name is Yan-Bin Wu. I'm a senior researcher with the ISTO of Japan, and this work is done under the Road to the L4 project, which is a project funded by Japanese government. And the goal is to deliver automated vehicle and automated driving on the public sector, especially those automated buses and automated trucks. So this slide, actually, the discussions already happened. So we all know there is a huge gap between SAE level 2 vehicle and the full automation, where there is no driver inside the vehicle. So to realize this kind of driverless vehicle, what we need to do is to bridge this gap. And currently what we do is to use remote driving or remote operation. So what we see this is that, okay, we can have different kind of use cases. We can have different, each bar represents one type of models. So we can have fully continuously remote driving, and we can have event-based remote driving. Here I want to emphasize that those event-based remote driving shouldn't be together with the SAE level 2 vehicle. But which means that the intervention request must be issued with a pre-lead time for the remote operator to intervene, but there shouldn't be the remote operator initiated intervention. So that's not feasible, I think, in many aspects. And also remote assistance, as that shows in the axis. So with the increase of the automation capability, also related to ODD. So with a smaller ODD, we can have a higher level of automation, but with a larger ODD, we want to enlarge the ODD, then we will have more functions that are realized by remote driving or remote assistance. So, well, that's a very complex issue, right? We have to consider which type of model we want to deliver. So we are talking so many different factors affecting the adoption of different remote type automated driving technology. What I see this is that we need to just consider safety and the business feasibility in the long term, which are the financial sustainability. So everything is decided by these two factors. As long as we can ensure safety and the case can provide us benefit, as mentioned by Azra, then it will be a good case. But if not, so we can do pilot study, we can do so many pilot experiments, but at last, it's just some waste, well, I don't say waste of money, but it's just some showcase of the fancy technology won't help the society. So I want to really emphasize on this. These two factors must be considered when deciding you want a remote driving or you want a remote assistance. Also, regarding business feasibility, one thing always overlooked by the engineers are the user acceptance benefit. So when we can remove a driver from the vehicle, it provides, let's consider the condition of robot taxi. It provides a perfect closed space for the customer. So this can also add some value for this taxi service. So when deciding to adopt those models, we should also consider how this kind of added value can benefit us in the long-term business models. Yeah, awkward. Pause. Yeah, not going. Next. Okay.
Julie, can you move the slide?
Why? I did nothing. So a different use case of the remote driving or event-based remote driving and remote assistance. I don't like remote driving very much, continuous remote. Let's start from the middle figure. That's one use case of a robot taxi company. They already provide commercial operation. And as we can see from the figure, they have this kind of direct control of pedals and steering wheel to provide event-based remote driving. Also, in the right side, the figure shows the remote workstation under our project, where there is no indirect control. Our approach is to let a remote operator to provide high-level orders and assistance to the remote vehicle. I want to go into the details. Next slide, please. Does this work? No. Anybody there? Oh, almost finished. We have 2 more slides. Just the 2, please. It's not working. So I have very good takeaways for you, but unfortunately, they don't want me to show you. So maybe let's just stop here.
It seems that we have some technical challenges. Okay, this is back. And if we can get to the next one, that would be great. Otherwise, we may have to start doing some panel discussion.
Yeah, next slide is some advertisement about our project.
Yeah, we do want you to give the opportunity to present that. Julie, can... Yeah.
So here you saw the picture of the bus. It's an automated bus. By the way, Michael, now Japan also legalized the operation of automated vehicles on public roads. And we are among the very first to get the permission from the government. And now the bus is under operation not now it's late time in Japan. It's late night, so tomorrow morning it will start to run. And our goal is to remove the safety driver. Now the cabin inside this bus is more like onboard authority. He is not in charge of the driving-related tasks, but more related to the passenger service and the passenger support. So this comes to the question that we also need to automate the passenger service-related tasks. If we want to remove the onboard driver from the driver's seat to a remote control center, we have to consider this. And this is actually one of the major concerns of the local companies or local bus companies. They want to provide service and maintain the competitiveness in the local area. So if we consider the passenger service related tasks, how should we call them? Can we call them remote assistance? So next slide, please. Okay, thank you. So I would say beyond, under the umbrella of remote operations, we have remote driving, event-based remote driving, remote assistance, which refer to the driving-related tasks. Also, remote passenger support, especially for middle-sized buses or public transportation. But if you ask me which model is the best, which model is the optimal for a driverless vehicle, I would say, well, no one fits all, one size fits all answer. Different use cases need different remote operation types, and the criteria are safety and long-term business feasibility. Also, from a human factor perspective, to balance and to allocate tasks as well as responsibilities between a remote operator and the automation system is a very important start to realize your target operation. So that's all from me. Thank you.
So if you both take a seat in the middle, behind the microphone. So let's see if there are any questions in the audience. I see 3 hands. Okay, we start over there. We have at least 4 questions.
Yes, hello. Good afternoon. My name is Sven Jansen from TNO. I was wondering where do we need the main innovations? Do we need the main innovations on the vehicle side, on the communication side, at the remote operating station side, or is the main innovation how we educate the remote operators? So where do you see that we need the main innovations?
Okay. According to my perspective, I would say the major innovation should be done on the automation side, because from the long-term view, as discussed with the time changes, the task allocation between automation and the remote side will change. So as long as we can say let the automation do most of the job, then the remote operator side, their tasks will be, the number of the tasks will be smaller and easier. So I see this as the perfect way for us to evolve to a driverless vehicle. But unfortunately, we all know that there won't be 100% reliable automation system. So that's the discussion already happened. We may still need remote assistance under some very specific circumstances. So that's my view.
I agree with some differences. I think it's important, as I said in my statement, to have a better automated driving system or function, because as soon as we have to intervene as remote assistant, it's always costly, I think, and it takes time, and we don't want the vehicle to stand still. In Germany, the vehicle, for example, according to the current law, has to perform a minimal risk maneuver, so we have a standstill. It's not on the flight. This takes time for the users. Acceptance will go down, I think, and also you have to, well, work, yeah? So, and I think we have a way to go for this, because the automated driving functions are not so good as we might think they are at the moment. We experience that always in different projects, and it's, well, there are some technical difficulties, but we will do that. And I think there's I don't know if it's a very big innovation because we are on a good way. It will take a little bit longer, but we are on this way. I think the main innovation is that we have, well, this new human being and we need a new workplace, and it might be completely different because you have, as I told you, the most important thing is to gain situation awareness in a concrete situation. For example, if you are an assistant, you have to jump into a traffic situation of any vehicle, let's say, spread all across the city. You don't know the situation, you don't know what is going on there at the moment. So you need quick information about the traffic situation, and then you have to decide what the vehicle is doing. And the main innovation for me are these highly technically evolved new workplaces for these assistants. And what we are doing, for example, in my research group is augmenting the video streams to guide visual attention and so on. And I think the big innovation and the automated driving function can also profit from this is that we need better sensor fusion, I guess. These are for me the main innovations. Connectivity is also important, but yeah, we're working on this as well. So if you're talking to German Telekom, for example, they say, we can do this, trust us. Let's see.
Okay, can I see all the hands? Because I think we have 1, 2, 3, 4, 5, 6 questions. You were first. Here, yeah, here. So you can only give 30-second answers.
Thanks. Clémentine Barbier, I'm from Keolis, so public transport operator. I just wanted a precision, Yangbin, when you were explaining that remote passenger support can be used for onboarding and alighting. What does this mean? Is it, for example, when there is someone in a wheelchair that has difficulties getting in or out? Or what is it? Thanks.
Yeah. Regarding the very specific use case where the handicapped passengers get on board, we have no way to do that remotely. That's the answer. We are considering that. But if we want to provide that kind of service, I think the only viable way is to send someone there to help the wheelchair to get on board. But what the message I showed in my slides, we also have the door opening and close issues. When the door open and close, we want to detect whether there are any onboard or getting off passengers. Any fancy AI models won't play that 100%. So what we do is to let the AI judge whether it's clear, the door is clear, and then let the remote operator to take a look and then give the order. So that's our approach. Thank you.
Yeah.
Hello, Christophe Rombaut from Flemish Agency for Road and Traffic. In the last couple of years, we've been developing but also deploying CITS services, so complementing information for human drivers. Now, when you talk about remote driving, they also still involve some level of human interactions, more with driving than with assistance. But have you considered also using CITS functions in the systems which are in development now, as it is indeed supporting human driving to some extent?
Yeah, of course, makes sense. But the entrance talk by our colleague from Continental, he said, we're developing automation or automated driving functions also with regard to, or let's say, what did he say? All the bricks we are developing in the moment. Let's say it was the emergency braking assistant. And the emergency braking assistant is one very good example. We had that in our BUST research group as well. And if you're talking to experts like university professors and so on, they insisted on, and they are true, that emergency braking assistance, level 2+ system, is not a level 4 system because it's not as reliable. And that's the main thing. You can, of course, use everything what's out there, but the difference is, and Yang Bin, you try to show this in your slide, there's a big gap between level 2, level 2+, level 4. And if you have remote driving out there, you can use on logistic hubs, or as we did, for example, in the swamps of South Sudan, you can use level 2+ functions for remote driving. But I wouldn't recommend to do this in Milano out there or something like that, because it's an assistance system. So at the end, the remote driver is in charge for braking, not the system, because the system is more or less regulated like no false alarms at the moment. But that's not with regard to safety. So probably somebody is dead out there, you know? That's the difference.
Okay, this is Nikura Zavi. I'm from Transport Research Center Verne from Tampere University. I conducted 2 rounds of survey throughout the year, so I can ask hundreds of questions, but I'm happy with 2 of them now. So what's your idea about the optimum, percentage of HMI that should be intuitive and perceptual at the moment for remote assisting particularly? And then the second one, I would like to ask about missing part of, the puzzle throughout today's speeches about remote operators' capabilities and skills that they should equip to. Thank you.
So I didn't understand the second question. Skills.
Yeah, we have to consider different model of the remote operation. If you are talking about remote driving, the skills, well, I can say it's a very challenging task. We need to train the remote driver for quite a lot of time to get used to the latency and get used to drive without the sense of speed. I myself sometimes did remote driving. When the speed went over 20 kilometers per hour, it's very scary. So I do believe that we need many training to ensure the remote driver is capable of doing that. But if you are talking about remote assistance, it's a different story. We also have some cognitive experiment. We found that it's not very difficult task. Instead, we need to maintain an optimal workload. Sometimes when the task is too boring, the remote operator easily gets sleepy and they feel not very good. And when the task is there are so many remote assistance tasks to be done by the remote operator, there will be overload. So I would say stories are different for remote driver and the remote assistance operator.
And I think it's not completely clear at the moment because we're just starting to create some knowledge about that and experiences. It's too early to say you really need these skills and that skills. There's a really bunch of different opinions on this. I can recommend you also, there was a big chapter and a sub-working group at the BUST, which is published, as you said, Lena, in English. You can download it for free. There's a whole chapter about skills and trainings for remote operators. And with regard to your first question, the optimal HMI, hard to answer, to be honest. Come to our light stand there, we suggest one that we think is good for remote assistance. But at the end, what we are doing is to have several research ideas and experiments, psychological experiments to improve the performance of remote assistance. But from a ADS perspective, and that's what I meant with we have to make progress with regard to sensor fusion, and that comes to AI questions, you know, AI assistance questions, AI partnership for these remote assistants. It's difficult at the moment because the system doesn't have the performance we envision what would be good to enhance the performance of these operators. And so the HMI will change as well. It's an evolving process, like everything when science progresses, you know.
Okay, I'd like to make a proposal. We go on for 4 minutes. We have 2 questions, and then we unfortunately have to close the session. Okay, everyone?
Okay. Okay, good afternoon. My name is Mikael Ivar. I work with the City of Gothenburg. Thank you for very interesting presentations. It seems to me that maybe the most relevant use case for using teleoperations is reduced situational awareness for the vehicle, at least in the long term, it seems. Maybe you don't agree. I think so. Then you need to have superior awareness from the remote tower or for the remote office. But I've seen very few slides discussing that. I'm thinking what type of information, what type of more capabilities do you foresee are the most relevant to give from the control tower to the vehicle? And if it's not about situational awareness, then please tell me what you think of it.
So again, your question is about remote driving or remote operation or remote assistance?
No, could be remote assistance, probably not remote driving, probably remote assistance.
Yeah, because when we talk about situational awareness, it's still that what kind of task are we expect the remote person to complete? If it's remote assistance, yeah, as mentioned by Michael, situational awareness, the remote operator have to jump in some specific scenario and to judge whether it's okay for the remote vehicle to continue to run or to go back to storage or something like that. In our app project, we already have some experiences of those very specific scenario that needs the judgment of remote operator. For example, this is true story. One day, the automated bus detects a fallen person on the road, and stops before the object there for like say minutes or seconds, and then it sends information to the safety driver. Although we are tested the remote operation system, it turns out that the detected fallen person was some weed in a person's shape. So the AI detected that as a person fell down on the ground. So for a human driver, it's like 1 second judgment. Okay, it's weed. Okay, go. Just send a go information to assist the remote operation system to the automated driving system to continue its journey. But if it's really like a person there, maybe we will need some other countermeasures. We will need some solutions to solve that. Yeah.
And as I understand it, the information perception is from the vehicle, but it's the remote operator interpretation that is superior to the vehicle interpretation.
Yes. Yes, we need plenty of cameras to provide the information of the bus. Yeah.
Okay, my first thing, my question is, are we Swiss with our legislation completely crazy in your mind? And you can, in the end, say yes or no. Yeah? So we have the legislation now in place which says you need an operator in the level 4 vehicle. You may use teledriving, we call it teledriving or remote driving at a low speed, at the distance. The people has to be in Switzerland because due to prosecution later on. And of course, we know nobody knows at the moment. So we did just a really open-minded legislation and said, well, it has to be very good once it's running in the business case on level 4 with very good minimal risk maneuvers, because when the minimal risk maneuver is stopping in just where it is, it's not worthy. It's not worthy. It causes traffic flux problems. It causes overtaking, very risky things. So we said we need it like that, and we try it to learn in pilots now at the moment. And of course, we don't have fleets of these cars. So all that things we heard about, in my view, it's quite technical or business orientated. It has to be safe. So back to the question. Are we completely mad now what we did, in your view, or is it just quite a risky vision?
Not at all.
Only yes or no?
Not at all.
I agree.
Okay, thank you, everyone. We have come to the end of this session. Thank you all for staying with us. Before giving a hand to all the speakers, I would also like to give a heads up to Elsa, who helped prepare the session and as an observer. So at the end, there will be a report, some summary of the session, and well, we will all pitch in. Thank you for that, and for all the speakers.